For our final group of shapes, we have circles. So we're finding the circumference and the area of a circle. And if you did buy yourself a nice compass, maybe it's the first time you get to put it to use, drawing yourself a circle. So we have two pieces of information labeled for our circle. First, we have the r, which is the radius, the distance from the center to the circle. And then we have d for diameter, which spans across the circle going through the center. And we know the relationship between the diameter and the radius as a diameter is equal to 2 times the length of the radius, or it's made up of 2 radii. The plural of radius is radii, with 2 i's on it, like so. And it is a relationship which we will see in the circumference formula, because you can see there's 2 different circumference formulae here. All right, so C for circumference is equal to pi times d, first of all. So think of that video of the tennis ball can. The tennis ball can had 3 tennis balls in it, so the height was approximately 3 tennis ball diameters high. But when I measured the distance around the can, the circumference, it was a little bit bigger than that. So it's a little bit bigger than 3 times the diameter, and a number that is a little bit bigger than 3, of course, is pi. Pi being approximately equal to 3.14159, and it just goes on and on forever. It's an irrational number. It's a very special irrational number, and it comes up in math a whole bunch, in geometry especially, right? Right beside it, we have another circumference formula. It's 2 times pi times the radius, because the diameter is equal to 2 times the radius, right? So which one of these formulas we use just depends on the context of the problem. Which are they giving us? Are they giving us the diameter? Are they giving us the radius? Or which one of those am I going to be using for a particular problem? Okay, and then finally we have our area formula as pi times the radius squared. Now in my experience, these 2 things get mixed up quite a bit. You can see the similarities between them, but where that 2 is, it makes a big deal, right? So I do find that a number of people will put a 2 in front of the pi r squared for the area formula, but don't do it. You're better than that. Area is just pi r squared, not 2 pi r squared. And then down in bold letters, because apparently it's important, pi is the ratio of a circle's circumference to its diameter, which we will see in our exercises right here. So let's take a look at the exercises. Number 1, the Large Hadron Collider is a circular tunnel that spans a 27-kilometer circumference. That's pretty big. All right, what is the area of the LHC ring, the Large Hadron Collider, right? All right, that one's pretty straightforward. It looks like I am going to have to work backwards on that one a little bit. Okay, that's fine. All right, on number 2, solve the circle circumference formula for pi. So this is the one that is referring to this bold statement that's down there at the bottom, okay? And then finally, number 3, write a formula for the area of a circle in terms of its circumference. So this is another one of those which, literal equation for sure, but also solving a system of equations, as we will see. So let's go to Notability. We'll hash some space, right? So circles, I don't know what you're feeling, but I think I'm feeling blue. Okay, I'm glad that we agree. So on number 1, the Large Hadron Collider being circular tunnel spanning a circumference of 27 kilometers. I certainly don't have enough space to write here, so it gets another page for sure. So I know my circumference is supposed to be 27 kilometers. Okay, and then we want to know what is the area of that ring. So the area is, I don't know, question mark, right? All right, now ordinarily the area is pi times the radius squared. So in order to figure out the area here, I need to know from the circumference, what's the radius? Radius, question mark. Since I need to know the radius, let's look back at our formula for circumference. I got 2 possibilities. I got pi times d, or I have 2 pi times r. Which one am I going to use? Since I need to figure out what the radius is, this is the one that makes the most amount of sense here, right? Okay, so we're going to take our 27 and set it equal to 2 pi times the radius. All right, so I'm going to show you some strategies through the course of this. This pi, I want you to start treating that thing like it is a variable, like it's an x. Like pretend like this is a 2x, and then we also are multiplying that times an r, right? And that way I can just manipulate pi just like I would manipulate any other kind of variable. I know that it's a number, and we know what that number is equal to, but we're going to treat it like the variable so that when it comes down to it, I only have to plug it into the calculator once at the very, very end. And then sometimes the problem doesn't want you to plug it into the calculator. It wants pi as part of your answer. Okay, and we're going to see problems like that throughout the year for sure. So what is the 2 pi doing to the r? What operation is implied there? It is a multiplication. So to get rid of it, I am going to divide both sides by 2 pi. The whole entire quantity, 2 pi. So it'll cancel out on the right-hand side, but it stays over there on the left-hand side. If the 2 divided evenly into the 27 over here, like the 27 was actually even, then I can simplify that fraction. But since it doesn't, I'm just going to write it down as 27 over 2 pi is equal to r. There's my radius. And I need that radius so that I can now plug it into the area formula to compute the area of the circle. So let's keep going with this one. So the area is equal to pi times 27 over 2 pi, which I'm squaring. Okay, so I can, at this point, put all of this into the calculator, but what I want to do is I actually want to have an opportunity of actually working with pi as a variable, treating it such, and seeing how that looks whenever we work out a problem, okay? So a is equal to pi times, and I'm going to square both the top and the bottom here. So 27 squared, I may not know off the top of my head, so I'm going to go ahead and throw that into the calculator. So 27 squared is 729. Oh, of course, I should have known that. 729 on top. And then on the bottom, I need to square both of these. I square the 2 and I square the pi. So obviously 2 squared is 4, but pi squared is, well, it's pi squared. There you go, just like that. Okay, and now I can, if you like it, I can put that pi that's on the outside over 1, and this would be a top times top and bottom times bottom type of situation, but notice where the pi's are. There's one up top, and then there's 2 factors of it on the bottom, which means that I could divide out one of these factors of pi here. That leaves a 1 up top, but I still have one of the pi factors on the bottom. And the whole entire area now can be rewritten as 729 divided by 4 pi. Let's think about what the units are supposed to be, okay? Let's see. Our circumference was measured in kilometers. Our circumference is a one-dimensional form of measurement, which is why it's in kilometers. The area is two-dimensional. It should be in kilometers squared. Now notice that I kept my equal sign here. I kept my equal sign here because this is the exact form of this answer. This is an exact answer. It is not approximated at all. We have every piece of information. I have to think, I'm trying to speak and spell the word answer, and I'm failing miserably. That looks right? Meh. Okay. It's the exact form of the answer. As soon as I plug this into the calculator and hit enter, even if I get 9 decimal places, it's now approximate. Because the pi there has an infinite number of decimal places, and every single irrational number, like pi, like the square root of 2, all of them are exactly the same way. So if I wanted the exact form of that answer, I keep that pi symbol as part of my answer. It's perfectly okay. As a matter of fact, like I said, some of our answers, I want you to leave the pi alone and just keep it in your answer. But just so that you can see what this is approximately, just to wrap our head around that. I will put that into the calculator. Yeah, like so. Now then, what I am going to suggest that you do is use this little fraction bar here. If you don't use the fraction bar, you will have to make sure that you put parentheses around the denominator there, or else it will divide by 4 and then multiply by pi. I'll show you all that because it'll be fun. So if I use the little fraction bar here, I put the 729 up top, and on the bottom, I put 4 times pi. I should have a pi button on here someplace. There it is. And hit enter, and it's this irrational number here. Notice that there's no toggle switch like this one to be able to turn that into a fraction, because you can't. It's irrational. So the best I can hope for is some sort of approximation, and maybe I approximate this with 3 decimal places. And when I look at that 3rd decimal place, the 9 behind it tells that 1, it's got to round up to a 2. So I would round this up to 58.012, and we already said that this is in kilometers squared. Okay, so watch what will happen if I don't use that little fraction bar and I just divide this like this. 729 divided by 4, and then throw the pi in there. This thing is so smart, it did it for me. Okay, let's see if I can mess it up. I want to be able to mess it up. 729 divided by, because your calculator does not do that kind of thing. The TI calculator, it puts the little division as a slash like this, 729 slash, and then you type in 4 pi. And then what happens is it treats the problem like this. Divides by 4, takes that answer and multiplies it by pi, which is not what you want to do. So in your calculator, you'd want to definitely make sure that you put parentheses around the 4 pi. This Desmos, though, it knows what's about to happen, so it prevents you from making that error, which is sort of handy. Okay, there we go. So I am going to box this one, and notice what I did on the previous one, which was a fatal error. I boxed it in blue, and it should have been in pink, like so. Okay, so speaking of exact answer, the second one here is the approximate form of that answer. And any irrational number, anytime we're dealing with irrational numbers, and like I said, the square root of 2 would be an example of one of those. Pi would be an example of one. Pi over 4 is an example of an irrational number, and this is a weird one because it's already written as a fraction, but this fraction doesn't count as a rational number because it has pi on the top of it. So every single one of these kind of numbers has either an exact form or an approximate form. The exact form uses the symbol. This exact answer for the square root of 2 is just like you see it there, the square root of 2. And the exact answer for pi is just the symbol pi. Anytime I put it into the calculator and get in a decimal expansion for it, I'm now getting the approximation for that particular number. Okay, so I'm going to call this one here and then pick up number 2 and 3 in the next one.